All right, let me go ahead and take a look at these functions with you. I don't know if you can see up here in the top right-hand corner, I've typed the function from letter E. Now, when I type it in, it's a 3x caret 3 minus 2x caret 2 plus x minus 2. That's the way you type in exponents in a graphing app, is with a caret meaning the exponent. So that's letter E's function. I click the little checkbox and we can see how this graph plays out. In fact, if I zoom out just a little bit here, you can see the graph is this cubic curve that doesn't do a zigzag dip, okay? But what I told it to do was, because remember letter E, it said evaluate the area between 1 and 2. Well, there's 1, there's 2, and it shaded it in with a purple. Let me zoom back in again, and you can kind of see, in fact, I'm going to shift a little bit here. You can actually see almost a box here at the bottom, almost a box here. Going to be about 2/3 of a box less, but you kind of can see how the sliver just becomes smaller and smaller. Well, if you took all the little slivers and added them to these pieces, it actually tells you the area off to the side. Now it gives it as a decimal. 6.083 is almost exactly 6 1/12, which is the number of units we saw. If I were counting, I'd say, well, that's about 1, little over, almost 2, 2.5. Maybe this makes it 3. This is almost exactly 3.5. Maybe this makes it 4, 4 and almost a half, little over 4.5. Maybe this is up to 5 now. And you kind of just keep adding it together. So I might guesstimate around 6, with 6 1/12. This is the other function, the cubic function. I'm going to have to zoom out to show this here and shift a little bit. But you can see the pronounced N-looking curve developing if I zoom out a little bit more. And a little bit more. Okay, there's the cubic curve. Okay, really steep cubic. Come back in just a little bit. And I think on this one, we were evaluating the area from, this is one we just did. So this was -1 to 0. So if I select the area under the curve from -1 to 0, and you can see the area coming up here. Let me come down just a little bit here. All right. So you can see this shaft of area going up the side here. You see, I guess 4 full units, almost 5 full units of regular area, and then it starts to get cut off. Now here, if you look at the area, it says it's 13.995. We said it was 14. It's because I've given the line a certain thickness that's eaten into the area a little bit, but 14 units of area. And again, this is a kind of a cool feature. It's called GraphCalc. It's free download. I downloaded it years ago when I was in college. It's just something fun to play around with. You can track all kinds of different equations. Earlier in the hour, we had looked at that parabola. Remember, that was kind of shifted funny. Let me type that in here. So if I'm going to type it in, it was a 2x squared. So I'm going to do 2x caret 2. That's 2x squared minus 4x plus 1. And there's our parabola. Notice it's shifted down a little bit. And I think we'd evaluated it from 0 to 3, remember. Let me zoom in a little bit because I think we've got the room to do it here. So 0, you see that little sliver here, to 3. And we'll evaluate from 0 to 3. And again, you see the area up, area down, area up. There's the graphing look at it. And again, it gives you the area is exactly 3 units. So kind of neat there. What was that first one we did? The very first one we did was, let's go with a pink line here. It was x squared, so x caret 2 plus 1. And we evaluated this one from -1 to 2, I believe was what we did. So -1 to 2, and we found the area was exactly 6 square units. And again, there's what it looks like perfectly graphed. And you can see showing the area off to the side here is the 6 square units. So anyway, kind of fun to play with a graphing utility and actually see the area shaded in on perfect graphing as opposed to my graphing. I wanted a chance to show that to you there. All right, questions? All right.